Today, we're going to take a tour of humanity's single greatest outpost in the cosmos. It's a laboratory the size of a football field that's been our home in the heavens for decades, the International Space Station. So, to really get a feel for the ISS, you've got to wrap your head around its sheer speed. It is screaming around our planet at nearly 27,000 kilometers per hour. I mean, think about that. That's about 8 kilometers every single second. It's moving so fast that it circles the entire Earth every 90 minutes. For the astronauts on board, that means they get to see 16 sunrises and 16 sunsets every single day.
And that, right there, is a monumental achievement. Ever since the first crew arrived way back in the year 2000, the lights have always been on. Humanity has kept this unbroken presence off-planet, a continuous chain of people living and working in orbit for over 2 decades. Not for one single day has space been empty of us.
But that's the real question, isn't it? I mean, it's one thing to visit space, but it is a whole other ballgame to live there. How on earth do you handle the absolute basics, breathing, drinking, eating, in one of the most hostile environments you can possibly imagine?
Okay, let's get into the nitty-gritty. To make the ISS a livable home, engineers had to solve the most fundamental problems of survival. And what they came up with is nothing short of an engineering masterpiece.
The key to the whole thing is what's called a closed-loop system. You see, launching supplies from Earth is, well, astronomically expensive. We're talking thousands of dollars just to send up a single bottle of water. So the station has to be a self-sustaining ecosystem, recycling literally everything it possibly can.
And yes, that includes water. The station's system is so unbelievably efficient, it collects moisture from every source imaginable. The humidity from the astronauts' breath, the sweat from their daily exercise, and, yep, even their urine. All of that is then filtered and purified until it's actually cleaner than most of the tap water we have down here on Earth, totally ready to be used again.
And that recycled water isn't just for drinking, it's also crucial for the very air they breathe. The station uses a process called electrolysis, which is basically a fancy way of saying they zap the water with electricity. This splits the H2O molecules into hydrogen, which gets vented off into space, and that precious breathable oxygen, which gets pumped right back into the station's atmosphere. So, all this talk about recycling urine and water, it kind of leads us to the one question that I know you're thinking about. If everything just floats around up there, how in the world do you go to the bathroom? The answer, in a word, suction. The space toilet is basically a very, very sophisticated vacuum cleaner. There's a special funnel that uses airflow for liquids, and that goes straight into the water recycling system. For solid waste, there's a tiny seat over another vacuum tube. That waste gets packed up, stored, and eventually loaded onto departing cargo ships that are designed to burn up completely on re-entry. Talk about a fiery disposal, right?
So, okay, they've figured out how to survive. But that's just the baseline. That's not why we built the ISS. The real reason it exists is for the kind of science that can only be done in one totally unique condition: weightlessness.
See, here's the magic trick. When you take gravity out of the equation, you can do things that are just flat out impossible on Earth. Like, for instance, on the ground, gravity messes with how crystals form. But in space, in a constant state of free fall, scientists can grow these near-perfect protein crystals, and that has been a total game-changer for developing new drugs for diseases like muscular dystrophy and even cancer. It's a laboratory that is literally changing life down here on Earth.
And as incredible as the science is, the story of how they even built this thing, well, that's just as remarkable. It's a story about politics, engineering, and unbelievable cooperation on a global scale. You have to remember, at the end of the Cold War, that intense space race was over. Both the United States and Russia were looking at these ambitious, separate plans for space stations and realizing they were just financially crippling. So, in this huge, historic shift, these old rivals decided to pool their resources and expertise. The ISS became way more than a lab. It became this powerful symbol of peace.
But building it was like assembling the world's most complicated and expensive Lego set, all while it's moving at 27,000 kilometers per hour. It all started back in 1998 with just a single Russian module called Zarya. And then, over the next decade, piece by painstaking piece was launched and attached in orbit.
But right from the get-go, they hit a snag. A really classic engineering problem, actually. The Russian-built modules and the American-built modules used completely different docking systems.
It was exacted like trying to plug a European appliance into an American outlet. They were just fundamentally incompatible. And their fix for this is just a perfect example of the kind of problem-solving you need in space. The solution wasn't to scrap everything and start over, it was to build a bridge. They launched this special module that was basically a universal adapter. It had a Russian port on one end and an American port on the other, finally uniting the two halves of the station.
And this whole incredible construction job relied on a three-part orbital crew. First, you had the space shuttle, acting like a giant semi-truck, hauling these massive modules up into orbit. Then you had the robotic Canadarm, which was like the crane, grabbing the modules and moving them into place with millimeter precision. And finally, you had the spacewalking astronauts, the hands-on workers, doing the delicate, final tasks of bolting it all together.
But like any incredible piece of engineering, it can't last forever. After more than 2 decades of non-stop service, this magnificent orbiting home has a firm expiration date on the calendar.
The year is 2030. That's the date circled for the scheduled end of life for the International Space Station. After 3 decades in orbit, the plan is to take it out of service and guide it on one final one-way trip back to Earth.
So why bring it down? Well, to put it simply, like any house, it's just getting old. For over 20 years, it's been pelted by tiny micrometeoroids and subjected to these brutal temperature swings. This constant expanding and contracting is like bending a paperclip back and forth over and over. Eventually, it wears out. Small leaks have appeared, and honestly, the cost of maintenance is just getting way too high to justify.
And taking it down safely, well, that's a whole mission in itself, with a price tag that is frankly staggering. NASA has awarded a contract worth nearly $1 billion to SpaceX, not to build something new, but to develop a special vehicle, kind of like a space tow truck, that can safely push the station out of orbit.
Now, you can't just let a football field-sized object fall out of the sky wherever it wants, right? The plan is to perform a controlled deorbit, steering the massive structure toward the most remote place on our planet, Point Nemo. This spot in the South Pacific is literally called the Spacecraft Cemetery. It's the farthest point from any land, making sure all that debris falls harmlessly into the ocean.
So, as we look toward its final years, we're left to wonder, what's its true legacy going to be? The ISS proved that former enemies could build something magnificent together in the most challenging environment we know. Maybe its greatest achievement wasn't any single scientific discovery, but that simple, powerful idea that in the vastness of space, we're all on the same crew. What do you think we'll remember it for most?